Okay, this is going to be the fourth video on how to change rational functions into geometric power series. And if you haven't done it yet, I would definitely watch the first three videos in order, and it will get you up to the point that we are right now. Now, before we go on and actually work out a problem, let me just remind you one more time, as we've done in the previous videos, what a geometric series is. And that would be the summation of a times some common ratio to the n power. If you find the sum of a geometric series, hopefully you'll remember this formula. It's a divided by 1 minus r. And then finally, if you're working with a geometric series, the series converges when the absolute value of r is less than 1. So those are the things you need to start with. And again, if you watch the first three videos, you'll be very familiar with this. We're going to use the same process, sort of, in this video. So let's go on to the first problem. Now, the first problem was like this. And this looks very similar to problems that we've already done. But in this video, the difference is we will look at series that are not centered at x equals 0. So we've got this problem, and the variation on this is that suppose the series is centered at 1. So c is going to be equal to 1. Now, if you think back, this is going to add an extra step onto what you have to do here. You might remember when you were working with Taylor polynomials and Maclaurin polynomials, if it was centered at 0, you just had x. If it was centered at c, then you had x minus c. So the additional step here is going to do this. Since it's centered at c is equal to 1, the first thing you've got to do on these is to replace. So we will replace x with x minus c. Now in this problem, c is equal to 1, so we're going to replace x with x minus 1. So the initial step, and it's kind of like what we've done on those other ones, we'll go ahead and just write the original thing down. So the original problem was 1 divided by, and I'm going to do this. Here is 5, and I've got minus, and I think I'll put it in red just so it kind of stands out. I'm going to replace x with x minus 1. So when you first start off, if you're going to center it at 1, it's in this form right here, x minus c. c is equal to 1, so replace x with x minus 1. Now, this next step is a little confusing, so pay careful attention. It's easy to make a mistake on this. The idea is you can't just randomly add a negative 1 to this because you'll change the function. So the idea is if you add a negative 1, you have to add something else to replace it. So suppose that you're working with some other problem. If you added a 5, you'd have to make up for it by adding a negative 5. If you added a negative 7, you'd have to make up for it by adding a positive 7. Now in this case, and here's where it's a little bit easy to make a mistake here, and I think I'm going to switch to blue just to emphasize these. It looks like I added a negative 1 there, and it's tempting to do this, to say, well, to make up for that, I'll put a positive 1 right here. Now, if you do that, there's going to be a problem, and watch what it is. So that's not going to be the correct thing to do. So let's erase that right now, even though it looks like it'd be the right thing. When you added this negative 1 here, what you really added was this, the negative of a negative 1. Now, if it helps you on these problems, sometimes it's better to just come down here and do this. I'll write 5, and I'm going to go ahead and distribute that negative. So that becomes minus x plus 1. So what I really added here was this positive 1. And to make up for it, I'm going to have to add a negative 1 to balance it out. So what needs to go on the outside here is a negative 1. So again, it looks like you added a negative 1, but you really add the negative of a negative, which is a positive 1. To balance it out, you have to add a negative 1. So at the end of your first step, that's what you're going to have right there. And that's probably the easiest place to make a mistake on these entire problems. So you have to be real careful. Now, if this had been a plus out here, then if you had added a negative 1, you'd make up for it by adding a positive 1. But you have to take into the fact that negatives and parentheses and all that. Okay, now we'll rewrite this, and we'll write it like this. I'll make it be 1 divided by, and you can put these two numbers together. So 5 minus 1 would be 4. Then you've got minus, and then in parentheses, you've got an x minus 1. So again, you added a negative 1, but that's really the negative of a negative, which makes it a positive. To make up for it, you have to add a negative 1 to balance them out. and then go ahead and put the 5 and the negative 1 together and give you that. So that's probably the trickiest part of the whole process. Now at this point, this is going to become very much like the previous problems. Now in the next step, what I've got is this. I've got a number here, and I need to have a 1 here. This again using the same processes in the previous videos. So to change that 4 into a 1, I'm going to divide by 4. So I'll divide this by 4. But as always, whatever you do to one term, you've got to do the same thing to all the terms. So I have to divide that by 4, divide that by 4, and divide that by 4. And again, the object is to get a 1 right here. So that's going to give me, in the numerator, I'll have 1/4. Then this turned into a 1, which is what I wanted. Then I've got a minus, which is what I wanted. And now I've got x minus 1 divided by 4, and it looks like that. So I've got it in the right form. I needed a 1, I've got a 1. I needed a negative, I got a negative. And just like in those previous videos, whatever's in the numerator is going to become a, and what's in the parentheses here is going to become my common ratio. But again, the whole trick is this, just remember this step right here. Replace x with x minus c, and it changes the problem just a little bit. But at this point, we'll do just like all the other ones. Now, we've got them in the right form. We've got it in this form, so now we'll change it into summation form. So I'm going to come down here and make this b, and just like I've done in all the previous videos, I like to just write out the formula first. So I'll make this be the summation as n goes from 0 to infinity of a sub 0, or just a, times the common ratio raised to the n power. Now, plug in the things that you've got. So this is going to be n is equal to 0 to infinity, and in place of a is equal to 1/4. So I've got a 1/4. Then I've got the common ratio. The common ratio is x minus 1 divided by 4, all raised to the n power. So it looks like that. And now it's just a matter of kind of spreading things out and simplifying it just a little bit. And let's see, what I can do is this, is I'll raise both the numerator here to the n power and the denominator to the n power. So I'll rewrite this as summation is n equals 0 to infinity. Here is 1/4. And I'm going to write the numerator as x minus 1 to the n, and the denominator as 4 to the n. So you're just raising both things inside the parentheses to the n power. Now, you can think of this as being 4 to the first power. So in the denominator, you would have this. This would be the summation as n goes from 0 to infinity of, and you can put these two together. So 4 to the first times 4 to the n would be 4 to the n plus 1. So you can make this be 1 over 4 to the n plus 1 times x minus 1, all raised to the n power. And what that's going to be the rational function expressed as a geometric power series. So you've got the first part of the problem done. Now, next thing you need is the interval of convergence, and we'll use the same thing that we've always done. We'll make it be the absolute value of r is equal, or pardon me, less, not equal to, but less than 1. Now again, to find what r is, I always like to go back to the first step where I plugged it in. When I first plugged it in, that was a, and when I first plugged it in, that was r. So that's going to be r right there. So as I work this out, and I think we'll scoot this down just a little bit, this is going to be the absolute value of, and in place of r, put x minus 1 divided by 4, the absolute value of this has to be less than 1. Well, again, factor out the 1/4, so that's going to give you 1/4 of the absolute value of x minus 1 is less than 1, or x minus 1 is less than 1. And again, multiply both sides by 4, and you'd have the absolute value of x minus 1 is less than 4. And again, if the absolute value is less than 4, that means that x minus 1 is either less than a positive 4 or greater than a negative 4. And then finally, to solve this, since you've got an x minus 1 here, just add 1 here, add 1 here, and add 1 there, and you'll come up with negative 3 is less than, this will become x, and this is going to become 5. So that's going to be the interval of convergence. Or again, you can write it in interval notation as -3 and put a 5 here in open notation. Now again, the radius would be the distance from the center to the outer edge. So the radius is going to be 4. So the radius of convergence would be 4 if you needed the radius. Okay, so there's an example of the first problem. And again, the whole secret to it is just in the original problem, if you're going to center it at 1, then replace x with x minus 1. And we'll take a look at a second example here in just a second using another one that's not centered at 0. So let's take a look at the second example. Okay, now in this one, a little bit different. You're going to have a little bit more work to do. But in this case, here's the function, and this time you want to center it at x minus 3. And again, the very first step here is going to be to replace, so we'll put replace x with x minus c. But in this problem, c is going to be equal to, this would be x minus a minus 3. So in this case, we're going to replace with x plus 3. Now, next step, again, just to go ahead and rewrite this thing. So I'll rewrite it, starting with the original function. This would be 4 divided by, and I'll do just what I did before. Also, here's the 2, but I think just to make it stand out a little bit, I'm going to replace that x with over here an x plus 3. So if it's going to be centered at negative 3, you'd have an x plus 3 here. Then here's the minus 3. Now, since I added 3 inside the parentheses, the question becomes, what do I have to either add or subtract outside the parentheses? And again, if it helps you, sometimes I think it's easier just to come down and distribute this 2. So the question is, what did I really add there? Well, distribute the 2, and you'd get 2x plus 6 minus 3. So when you added that 3 there, what you really added was a plus 6. So to make up for it, you have to subtract 6 out here, so you'll wind up putting a negative 6 right there. And again, that's kind of the tricky part on this thing, is make sure you distribute. So you really didn't add a plus 3, you really added a plus 6. So to balance it out, you have to subtract 6 like this. Okay, so what that gives you, we'll move on to the next step. You've got a 4 in the numerator. We'll go across here. Now I'm going to go back to this thing again. This is going to be 2 times x plus 3. Put these two together and you'll have a minus 9. So now it's just a matter of changing this into this form up here, a divided by 1 minus s. Now first of all, just like we've always done, is I'd like to get the x, start out with a number first, followed by minus, and have the x second. So I'm just going to take one extra step and just switch these two. And I'll make this be 4 divided by, and all I'm doing here is just switching the negative 9 to the front, then putting a plus 2 times x plus 3 right here. And the whole reason for doing that is just now it's in the form of a number minus r. Okay, the next thing, you need a positive 1 for the number. So what you need to do, you've got a negative 9, you need a positive 1. So to change that negative 9 into a positive 1, go ahead and divide both of them by a negative 9. Now whatever you do to one term, you've got to do the same thing to all terms. So I'll divide by a negative 9, divide by a negative 9, and I think I'll put divide by a negative 9 right here. So what that's going to give me would be in the numerator, I think I'll put it over here. This is going to be, I've got a negative 4/9 in the numerator. Then this turned into a positive 1, which is what I wanted. And then I've got, now, at first you might think you have to change that from the negative of a negative, but when you divide by this negative, it changes it into a negative 2/9. I think I'll put this in parentheses, times x plus 3. So it looks like that. And really, I've got it in the form I want now. I needed a 1, I've got a 1. I needed a negative, I've got a negative. And then for everything else is this thing right here is A, and all of this together is R. So now you're ready to write it in summation notation. So we'll go down and we'll put it in this notation right here. And just like in those previous problems, I'm going to start out by just writing the formula down. So that's going to be the summation as n goes from 0 to infinity. And again, I'll put a sub 0 times r raised to the n power. So plugging in the things that I know, let's see here. So a is minus 4 ninths. So I'm going to put that in parentheses, minus 4 ninths times r. And r is going to be, I think I'll actually write it in just like it is. R is going to be 2 ninths times x plus 3, the whole thing raised to the n power. So it'll look like that. Okay, and I'll put parentheses around that. So now this is just a matter of kind of dressing things up here. So what this is going to be, we'll make it be the summation as n goes from 0 to infinity of, first of all, here's the negative 4 ninths. And I'll do kind of the same thing we've done before. I'm going to raise everything in there. And actually, I put this parentheses in the wrong spot. That parentheses should really be right there. So I want the whole thing raised to the n power. Now, you'll raise the 2 to the n power, 9 to the n power, and the x plus 3 to the n power. So we'll write that as, this part is going to become 2 to the n divided by, this one's going to become 9 to the n, and then I'll have x plus 3 to the n power. So it looks like that. Now, kind of like we've done in those previous ones, I can do this. Think of this 9 as being a 9 to the first power. So in the final form of this thing, I can write it as the summation as n equals 0 to infinity. First of all, here's the negative 4, so I've got a negative 4. Then here's a 2 to the n, so I've got a 2 to the n. Divided by, now here you can add these two exponents together. So 9 to the n times 9 at the first becomes 9 to the n plus 1. And then finally out here you've got the x plus 3, the whole thing to the n power. So it took a while to get there, but that's going to be the geometric power series that represents that rational function. So you got that part done. Now the next part is to find the interval of convergence. And again, rather than looking for r in this part, my suggestion is always go back where you first plugged it in. When you first plugged it in, that was a, and this whole thing right here is r. So that's what you're going to use for r. So now, as you solve this, you'll start out with the absolute value r has to be less than 1. So now it's just a matter of plugging things in. So this becomes the absolute value, and in place of r, put 2 ninths times x plus 3. And all of that has to be less than 1. Again, you can bring the 2 ninths outside the absolute value, so that's going to be 2 ninths of the absolute value of x plus 3. That has to be less than 1. Now, it's a fraction, so invert and multiply. That's going to be the absolute value of x plus 3 has to be less than, and when you bring it over to this side, it becomes 1 times 9 halves. Okay, now I think we'll scoot this up here. So what that's going to be is that means that x plus 3 has to be less than positive 9 halves, and it has to be greater than a negative 9 halves. Now, finally, you'll need to subtract 3 from both parts here. So what I think I'll do, rather than subtracting 3, I think I'm going to subtract 6 halves, which would be 3. Then I'll subtract 6 halves over here. Then I'll subtract 6 halves here. So I'll subtract 6 halves from each part. Now, when you do that, the 9 and the 6 is actually going to give you minus 15 halves. These two will cancel out. That's going to be less than x. And then This is going to be 9 minus 6. This would be 3/2. And that's going to be the interval of convergence. Or you can write it in interval notation as minus 15/2 to a positive 3/2. And the radius of convergence would be whatever the absolute value is. So from the center, you will go 9/2 to the right and 9/2 to the left. So the radius of convergence would be 9/2. So there's another example using something that's not centered. And again, going back up to the top, kind of the trick on these is when you first start, just replace x with x minus c, which in this case turns into an x plus c. And to me, the trickiest part of these is trying to figure out this thing right here. Is if you added 3 here, just remember you really added 6. So to make up for it, you have to subtract 6, then you combine them. And it's kind of easy to think, well, I added 3 here, I'll subtract 3, but it's 2 times 3. So watch out for that easy mistake to make. So there's a couple of examples on how to handle geometric power series where it's not centered at the origin.